Good morning and welcome back. I hope y'all had a great spring break. It's definitely it's been like 2 weeks since I seen you guys last, so hope everything's going great. I hope you had a great start to your week and that your odd period classes went well the last couple days. Today we've got a couple things to get through. We're gonna look at some stuff as far as preparation for AP testing, which if you had AP classes yesterday or the day before, you may have already seen this information. You may have already done the survey that'll ask you to do. And if you have, please don't do it again. You don't have to do it more than once. But if you have not, if this is the first time you're seeing this information, please follow along, take the survey, so that your school and the district has all the proper information needed for you to successfully take your AP exams. All right, so we're going to start with that, and then we will complete our lesson for section 9.2 that we started 2 weeks ago. So we will do a little bit of review from what we saw a couple weeks ago, and then get into some examples for you guys to work with, and then that'll be the day. And then we'll get into section 9.3 tomorrow. All right, so we'll start with our little short presentation about AP testing and starting our preparations for that. And then we'll get into our lesson. So let me share my screen. All right, so this is just a little kind of some information. Some of it applies specifically to Orange Glen because that's what I was given. But many of the things apply to all the school sites. And if you have a school site specific question, you can please let me know and I'll make sure to ask the proper people to help you get those answers. This survey must be done by Monday, April 12th. So please keep that in mind, but it only takes like 5 minutes or less. So some quick information, AP World Languages, AP World Language exams, right? And this is at Orange Glen High School. However, the same idea applies to any of the school sites. The following AP exams are required to be taken in person at school due to the nature of the exam. These will not be able to be done remotely and digitally, so to say. That's the AP Spanish Language, AP Spanish Literature, and AP French Language. Right, those must be taken in person. So if you're taking those classes and you're planning on taking those exams, please be prepared to have to take those in person. The digital exams, all right, since the district decided to take the third administration of the AP exams, those are starting June 1st and go through June 11th. There's like a morning testing window and an afternoon testing window. The AP Stats exam will be on Thursday, June 10th, starting at 1 p.m. All right, and that's the stats one. Please, you should have gotten a copy of this information to the email that you are registered with on My AP, right, the AP Classroom, which may or may not be your school email. So please check that email to see if you've gotten any information about AP testing and schedule and such like that. I'll make this presentation available as well, though, so you can have this through the Canvas course. All right, but these are the testing dates and times. If you have other tests that you're taking, please refer to this list. If you're taking an AP exam, any AP exam, not just AP Stats, any AP exam, you need to take this survey, which I always forget that I need to copy the link before I start the presentation. Nope, it's not going to do it that way. And I'll put this link in the chat so you can take the survey if you have not done so in another class, just in case. There we go. All right, this is important. It takes about 5 minutes or less. If you need to speak with your family about some of the questions, please fill it out during the next class or next possible time, but no later than April 12th at 3 o'clock. That's Monday. Why is this survey required for all students? We need to know if you're unable to test at home. We also need to know your technology needs. You cannot use a phone or a tablet to take the test this year. Last year, that was an option. This year, it is not. You must use a laptop or a desktop computer. Once again, if you're taking AP Spanish Language, AP French Language, Italian, AP Spanish Lit, you will be testing at school. These exams are not available for at-home digital format due to the nature of the exam. Right. The survey looks like this. This is the first page. You need to provide your student information, what high school you go to, and what grade level you're in. And then you need to select all the AP exams you're registered to take in My AP, all of them, not just AP Stats because you're sitting in AP Stats. If you're taking multiple exams, select every exam that you're registered to take. Any and all, digital or in person. Next, you need to say whether or not you have the necessary technology. Right, you have, yes, I have a laptop or desktop to take my digital exams at home. No, I need to be issued one. Right, make the proper selection. If you need to be issued a laptop, IT and everything will get in contact with you to help you schedule picking up a device. Then you need to confirm that you're able to take these digital exams at home. Say, yes, I can, or I would like to ask permission to take the digital exams at school. Right. If you're asking for permission to take the exams at school, you then get one more question which says, tell us why you want permission to take this test at school. Right. We need to make sure that each school site, for the amount of students that want to take the test at school, the digital exam at school, that we have the proper accommodations and social distancing and all that fun stuff while the exams are being given. And that we have the proper amount of like proctors and things like that. So we need this information. And then that will be the end of it. The end of the survey, you'll submit it, and that is all you need to do. That is like one of our first steps on getting ready for taking the AP exams. Is there any questions about this? Okie dokie. So then that leads us to the second part of our 9.2 lesson. So if you've been taking notes, I suggest you grab your notes. If you have not been taking notes, but you have something to write with and to write on, you should have that ready as well. You're going to be asked to do some math, and hopefully you have a calculator as well. So I'm going to drop the link in the chat for the Desmos activity, which will be limited to the screens that we saw in the previous class a couple weeks ago. There it is. The link is in the chat. So you guys please join back into that Desmos activity. And while everyone gets joined up there, you're welcome to go back through the exercises the notes and exercises we saw last class. I will specifically be going over a few of those pages just to make sure that we review a little bit before we get into questions, and then we'll get going. First, to review kind of the things, the key ideas that we should have taken away from the previous lesson, all right, 2 weeks ago. It was a while ago. We're going to start by looking at screen 3, right, the check conditions screen. Right, so you can follow along using the shared screen in Teams, or you can follow along on your own Desmos activity screen. That is up to you. But again, for checking conditions, and we're talking about tests about a population proportion. Right? Before we can conduct a significance test about a proportion, we must check the same 3 conditions that we had to check before constructing a confidence interval for a population proportion. Right, we need to make sure that the data come from a well-designed random sample. Right? We have that random condition. or randomized experiment. We need to check the 10% condition when we're sampling without replacement. And we need to check the large counts condition, meaning that we have at least 10 successes and at least 10 failures in our sample. If those three conditions are met, then we can start performing a significance test. Right, so we need to remember those three conditions. Next, I'm going to skip over to the one sample z-test for a proportion screen. That is screen 7. All right, once we've checked conditions, we can then start doing our significance test. All right, and for that, we will be using the one sample z-test for proportion inference method. All right, we will find the z statistic and then find the p-value that goes along with it. All right, we need to choose an SRS of size n from a large population that contains an unknown proportion p of successes to test the hypothesis. Null hypothesis such that p equals p naught, we compute the z statistic. All right, z is equal to p hat, the sample proportion, minus p, which is the hypothesis proportion, divided by the square root of p naught, the hypothesis proportion, times 1 minus p naught, divided by n. All right, once we have this z statistic, which is very similar to a z-score that we can calculate with a normal distribution, we find the p-value by calculating the probability of getting a z-statistic this large or larger in the direction specified by the alternative hypothesis, h sub a. Essentially, we take this z-statistic and we use table A, or we can use functions on our calculator to find the proportion under the curve. We look for the direction that the alternative is telling us to look, right? Is the alternative greater than the null hypothesis? Is it less than the null hypothesis? Or is it just not equal to, in which case we have a two-sided test? Right, and we find the area under the curve corresponding to that direction. All right. Again, we'll see examples of this. Is there any questions about the one sample z-test for a proportion? And the last piece of our review here is that now that we know the things we need to use, we should always be using our 4-step process for conducting a significance test. State, plan, do, conclude, all right? We need to state what hypotheses do you want to test and at what significance level. Always remember to define any parameters you use. In this case, we're going to be using P. We need to tell the reader what P represents, right? Is it the proportion of students who are left-handed at a school, right? What is P representing? Plan, choose the appropriate inference method. One sample z-test for population proportion. That's what we're using right now. That is our inference method. Right? Check conditions. Right? Random 10% large counts. Once conditions are checked and if the conditions are met, we perform calculations. We compute the test statistic, in this case the z statistic, and then find the p-value. We can find that p-value using table A or technology. Lastly, based on the p-value and how it relates to our significance level alpha, we make a conclusion. We make a decision about the hypothesis in the context of the problem. All right, recall, if the p-value is greater than alpha, right, then we fail to reject the null hypothesis. We do not have evidence for the alternative. If the p-value is less than alpha, then we reject the null hypothesis and we have convincing evidence for the alternative. Right, and hopefully that's in your notes somewhere with section 9.1 stuff. All right, and so those are the main things we need to do a significance test. Check conditions, one sample z-test, and 4-step process. So with that, we're going to get to our first example problem for you guys to work through. Right, and this is our side effects practice with the 4-step process. Right? A drug manufacturer claims that less than 10% of patients who take its new drug for treating Alzheimer's disease will experience nausea. To test this claim, researchers conduct an experiment. They give the new drug to a random sample of 300 out of 5,000 Alzheimer's patients whose families have given informed consent for the patients to participate in the study. In all, 25 of the subjects experienced nausea. Use the data to perform a test of the drug manufacturer's claim at the alpha equals 0.05 significance level. Right here we have a link to the formula sheets and tables if you need those. And then lastly, I recommend doing your work on paper and then uploading a picture of your work using the upload image option down here, the bottom left corner of the text entry box, or you are more than welcome to just type in your responses and your work in here. All right. Now, be mindful. The first thing you should do is essentially collect all the data and information you have from the context. What's the claim? What's the null hypothesis? What's the alternative hypothesis? Do I know the population size? What's my sample size? Right? What's my sample proportion? Right? These are all things you can pull out of the context, and it'll help you get set up in the right direction. All right, we are going to talk about this one and get on the same page here. All right, so if you would mind switching over to the shared screen, because I'm going to pull up OneNote that has work for this problem done here. Also, those of you who did submit answers into here, a lot of your work looks good. There's, I think, a few kind of misconceptions on how to present things that I think is going on. So we'll go through the work here and try to answer any questions or clarify some possible misunderstandings. All right, so here's the work for this problem using the four-step process. Now, I do understand that given the time and given the ways that you guys are able to submit your responses in Desmos, getting all the minutia and detail for the four-step process into Desmos might be difficult and time consuming. So I understand at some point just giving me the results or giving me the kind of the bottom line stuff. However, you should be practicing using this four-step process in some way, whether that's just writing it down on paper so that it's something easier to write, and then in Desmos giving me the final results, that's fine. But you need to practice. All right, so for our four-step process here, before I start the four-step process, I always like to put together all the data from the context. Right? In this case, the null hypothesis is going to be p equaling 0.1. Right? And the null hypothesis would be that 10% or more possibly experience nausea. The alternative, which is the claim of the drug manufacturer, is that less than 10% will experience nausea, so p is less than 0.1. We have a sample size of 300. We also know the population size that we're sampling from, and that is 5,000 patients. Right? We don't always get this information. In this case, we did, and we can use this to specifically confirm the 10% condition. Right? The sample proportion we get is 25 out of 300. I've rounded that to 0.083. It's also fine to keep extra decimal places in 0.0833. This is a repeating decimal. It's just going to have threes forever. And then lastly, our significance level, right, is alpha equaling 0.05. So this is just, I like to put all this information at the beginning of my process here so that I have it and I don't have to go back into the context to find it. Next, we do our first step, right, in the four-step process, that is state. We want to perform a significance test on the hypotheses, null hypothesis such that p equals 0.1 versus the alternative hypothesis that p is less than 0.1. where P is the true proportion of the 5,000 Alzheimer's patients. Notice that I'm referring back to the population I'm sampling from, because that's the only thing I can perform inference on. Right? Who would experience nausea while taking the drug at an alpha equaling 0.05 significance level? So I have three specific parts in this statement. I've given my hypotheses. I've described the parameter and what it means in context. And I've given the reader what significance level I'll be using. Right? We need those parts in there. If you're not given a significance level to use, like in this problem, a good default is just to use alpha equaling 0.05. Right? It's a very common one to use. So if one's not provided, we can use that. In this case, it was. So that's step one. Step two is the planning part. Right? If conditions are met, we will do a one sample z-test for the population proportion P. All right? So I'm saying if conditions are met, that's pretty standard. And then essentially I'm saying the inference method that I will be using when the conditions are met. That needs to be part of this statement. We then check our conditions. Random, the sample was chosen randomly. We were told that in the context. 10%, 300 divided by 5,000 is 0.06, which is less than 0.1. 10% condition has been met. And lastly, large counts. 0.1 times 300 is 30, which is greater than or equal to 10. And 0.9 times 300 is 270, which is also greater than or equal to 10. We're good on the large counts. All conditions have been met, so now we move forward with our calculations and the do step. Okay, and the first part of that is calculating the z statistic. Right, so we have z equals p hat minus p divided by the square root of p times 1 minus p naught divided by n. It's very important to know that that whole fraction there is part of the square root. Right, we're taking the square root of this whole division thing right here. Right, so then we get 0.083, or if you kept another decimal place, 0.0833 minus 0.1 divided by the square root of 0.1 times 0.9 divided by 300. We get all this stuff. If you use 0.083, you get negative 0.98. If you used 0.0833, you'll get negative 0.96. Right? It's just a matter of rounding and rounding error. Both of them will ultimately give you the correct conclusion. All right. Lastly, we use this z statistic to find the p-value using table A. All right. And so we go to table A, the negative side of table A, and we find the z-score of negative 0.98. Right. And we get approximately 0.1635. This p-value is greater than 0.05, so that will lead us to fail to reject the null hypothesis. This here is not a conclusion. It's just the end of my calculations, and it allows me to know what to do in my conclusion. It's simply part of the work. All right, the conclusion is an actual statement, and it must tie our results back to the original context. Right? Because the p-value 0.1635 is greater than alpha equaling 0.05, we fail to reject the null hypothesis. We do not have convincing evidence that the true proportion of these 5,000 Alzheimer's patients who would experience nausea while taking the new drug will be less than 10%. Right? If all that you say, sorry, my lights went out. If all that you say is that we do not have convincing evidence to support this, the claim, you're wrong. You're not going to get credit for that result. You'll get partial credit on an AP exam. It's not like you'll get no points, but you will not get credit for having the correct result because you just basically said a generic statement that has nothing to do with the context. You need to say what that result means in context. Okay? Are there any questions? Is there anything I can clarify? So then we're going to move on to our next part here, and that is talking about type 2 errors and the power of a test. All right. The significance test makes a type 2 error when it fails to reject a null hypothesis that is really false. All right, so if your data does not support the alternative, if you do not have sufficient evidence to support the alternative, however, the alternative was supposed to be true, that's a type 2 error. All right. There are many values of the parameter that make the alternative hypothesis true, so we concentrate on one value. The probability of making a type 2 error depends on several factors, including the actual value of the parameter. A high probability of type 2 error for a specific alternative parameter value means that the test is not sensitive enough to usually detect that alternative. You're not going to be asked to calculate a type 2 error or the power of a test. You might be given one and asked to find the other using the other one, because they are related. We'll get to that shortly. But you're not going to be asked to calculate these numbers yet. The power of a test against a specific alternative is the probability that the test will reject the null hypothesis at a chosen significance level alpha when the specified alternative value of the parameter is true. Okay. And so having a higher power gives us essentially more confidence that our significance test will accurately reject the null hypothesis if the actual proportion is the specified value that we have. All right. To help this make a little more sense, we're going to look at an example using a video from AP Daily that I think is helpful. So this should work. And let me know if the volume's not working. I think I have it set up, but
level.
Sometimes.
Now let's talk about power and type 2 errors. In many contexts, a type 2 error is more consequential. I say this because in most research, researchers are trying to show that the alternative is true. And if they make a type 2 error, that means they didn't find convincing evidence the alternative is true, when it really is. So their suspicions were correct, they just didn't get the data to back up their suspicions. So for a researcher, a type 2 error is really bad news. Well, they came up with a word to talk about the probability of avoiding a type 2 error, and that word is power. So power is the probability of avoiding a type 2 error. The power of a test, then, is the probability that a test will correctly reject a false null hypothesis. Notice it says correctly there. Power is describes a correct decision. So the null hypothesis is false, and our data suggests that it's false, gives us convincing evidence that it's false. So power is the probability that we find convincing evidence for the alternative when the alternative really is true. That means the probability of a type 2 error is 1 minus the power. Remember, if power is the probability we avoid a type 2 error, then 1 minus the power is the probability of a type 2 error. Now let's look at an example to put this in context. To investigate if high school students associate the color green with being more natural, 2 student researchers randomly selected 30 students from their school. Each student was asked to taste 2 cups of lemonade in random order and state which one tasted more natural. One of the cups was green and the other cup was white. And unknown to the taste testers, was the fact that both cups contained the same brand of lemonade. From previous videos, remember that we talked about the null hypothesis being p equals 0.5 and the alternative p greater than 0.5, where p is the proportion of all students at this school who would choose the green cup. Now, suppose that researchers used a significance level of 0.05 and that the power of the test against an alternative of p equals 0.64 is 0.45. Interpret the power in context, then find the probability of a type 1 and a type 2 error. So before we answer these questions, I want to reread the question because that first sentence might sound a little confusing. It says, suppose that the researchers used a significance level of 0.05. Well, that's pretty standard. And that the power of the test against an alternative of p equals 0.64 is 0.45. So we're saying the power is 0.45, and it's that number for the specific, the truth is 0.64. We're not going to get into the calculations in this video, but the calculation of power depends on what the true value is, if it's something different than the null. So in this case, we're assuming the true value is 0.64, and then we've done calculations to show that the power equals to 0.45. Again, you don't need to worry about where those numbers come from. I just want to make sure you understand what it's describing. So interpret the power in context, and then we'll find the probability of a type 1 and a type 2 error. So here's what the power means. If the true proportion of students who would choose the green cup is 0.64, then there's a 0.45 probability that we find convincing evidence that more than 50% of students would choose the green cup. In other words, there's a 45% chance that we'd find convincing evidence for the alternative hypothesis. Now, as far as the probabilities, the probability of a type 1 error is equal to the significance level. That's easy, 0.05. And the probability of a type 2 error is 1 minus the power. So remember, power is 0.45, and so the probability of a type 2 error is 1 minus 0.45, or 0.55. Now let's talk about what factors affect power. Assuming everything.
All right, so hopefully that helped kind of make a little more sense out of type 2 error and power. And again, you're not going to be asked to be able to calculate these, but if you're given one, like if you're given the power, you should be able to use that to find the probability of a type 2 error. If you're given the probability of a type 2 error, you should be able to use that to calculate the power. You also need to know what they mean, like, and be able to interpret those values. So again, the significance level of a test is the probability of reaching the wrong conclusion when the null hypothesis is true. The power of a test to detect a specific alternative is the probability of reaching the right conclusion when the alternative is true. All right, so this first sentence is type 1 error. This is power. We can just as easily describe the test by giving the probability of making a type 2 error, sometimes called beta. That's a Greek letter B. So we have power and type 2 error here. The power of a test against any alternative is 1 minus the probability of a type 2 error. For the alternative, that is, power equals 1 minus beta. And we have the other side of that, which was on the video, the probability of, or the probability of a type 2 error is equal to 1 minus the power. These are complementary values. All right. Increasing the power of a significance test can be helpful because, again, the higher the power, the more likely we will correctly find evidence for the alternative, which when you're a researcher, that's usually what you're looking for. You want evidence of your claim. There are specific ways we can increase the power of a test. One is by increasing the sample size. We can also increase the significance level. Right? And we all know, I mean, increasing the sample size is essentially like one of our best tools to get more accurate results. Right. And then the last one here, increasing the difference between the null and alternative parameter values. That is important to detect. This difference you usually have a little or no power to control. All right. So, and this is because you're given the context of these problems. You're not really at liberty to change the hypotheses to different values. So typically you're going to rely on increasing a sample size or increasing the significance level. So our last question here, referring back to screen 12 on our side effects problem. Part A, describe a type 1 error and type 2 error in this setting. Don't just tell me the definition of a type 1 and a type 2 error. Tell me what they would be in that context, and explain the consequences of each in that context. B, the test has a power of 0.54 to detect that the true probability is 0.05, or an alternative of, I'm sorry, the alternative of 0.07. Explain what this means. Lastly, identify 2 ways to increase the power in part B. Alrighty, guys. We're going to talk about this one. I know that you're probably not done writing responses for all these, and that is okay. We're running a little bit over an hour right now, so I want to get things wrapped up for you guys. So again, let's talk about these. So if you're looking at the shared screen, I have responses for these 3 questions here. So for a type 1 error, remember a type 1 error is rejecting the null hypothesis when the null hypothesis is actually true. So in this case, in this context, a type 1 error would be finding convincing evidence that less than 10% of patients would suffer nausea after using the drug, when in reality, at least 10% would. All right, that would be a type 1 error. The consequence would be that the new drug is used on more patients, leading to excessive nausea. Type 2 error is failing to reject the null hypothesis when the alternative is true. Sorry. So in this case, failing to find convincing evidence that less than 10% would suffer from nausea, when in reality, less than 10% would. Right? And the consequence is the new drug is used less, even though it rarely causes nausea. Right? So you need to be careful about this because it does get kind of confusing, and because we're using verbiage like reject, fail to reject, instead of saying true or false kind of thing, it's not as like black and white. You just need practice with it. Is there anything I can clarify about part A? So then part B, if the true proportion of Alzheimer's patients who would experience nausea is really 0.07, there is a 0.54 probability that the result of the study would provide convincing evidence the true proportion is less than 0.1. Right, so essentially the power here of 0.54 is saying we have a 54% chance of correctly rejecting the null hypothesis because the true proportion is 0.07 and we find convincing evidence for our claim. And part C, we can increase the sample size or increase the significance level. Those are the 2 possible ways we can increase the power. Most reasonable. Are there any questions? Is there anything I can clarify or explain better? Okay. All right, so we'll stop sharing the screen here. So that is the end of the lesson. That is all we're going to cover here in section 9.2. I do want to remind you there are lots of resources, videos, study guide, notes, practice problems, solutions to those problems in the chapter 9 module. All right, please take advantage of these resources. As we saw, the AP Daily videos are nice. They're short and sweet, but they give you really nice examples. So take a look at those things, especially if some of these concepts are confusing to you right now. Use the available resources. If you have any other questions, comments, concerns, anything you would like help on, please feel free to stick around right now and ask for help, or send me an email, send me a message on Teams. Otherwise, get a hold of me, and I'm happy to help. And that's it for today. Have a great rest of your day, and I will see you all tomorrow.